So, yeah, welcome. Maybe it's the last session today. And why I'm doing this, because many people are interested in my clients. And for me, it is actually a continuation of this, what I did all the time. So all the DevOpses and the last 20 years. And even the source code looks the same, but the runtime changed. So this is maybe a challenge for you. So if you have questions, or you say, okay, this doesn't work for you, whatever, I will try to answer the question. And what usually happens, I will have one slide more the next time with your question. This is what happens the last time. I was at the Java user group, and they asked many questions. And the AXDV last week, they asked also many questions. So in the train yesterday, I created some more slides to answer some questions up front. So fun accident, what this is AWS Industries. Why that? I was at a nice conference called JCon, and someone asked me, are you working for the company called AWS? And I say, yeah, there's no company, it's just me. But I got the idea, maybe I create a DNS, and website with AWS Industries. If you go there, you will find all the links, GitHub, Twitter, whatever from me. It's just maybe the fastest website on the internet, because it's just maybe 5K, it's just, just a few links. Okay, so I still like Java. That's the interesting part. So I spent 100% with Java on the backend, yeah, 100%. And in the front end, just pure JavaScript. This is what I'm doing right now. JavaScript with JSDoc, so it behaves like TypeScript, but it's a different story. Okay, I also have a podcast. Maybe the last one is interesting. It was recently, and this is the reason why I'm here. I had a nice chat with Stefan, and we had chat how DevOps and Java Polis happened. And he mentioned, hey, CFP is closing in 1 week or something like this. Like, oh, then maybe I will submit a talk, and now I'm here. This is the entire story. So this is the podcast. So AXDV, any questions left? First Monday of the month, I'm answering your questions. What cool is this show runs for 115 episodes. So what I'm doing right now, time traveling machine. So we look 100 episodes back, so roughly 8 years, and we're revisiting, the old questions. And spoiler, it's the same question asked, every 10 years, so there's no difference actually. So and also accident. So I have daily Java shorts because it's fun. What I usually do, if there are boring meetings via Zoom or Teams, so there's enough time to write some code, and then recording happens afterwards, and a coffee, and then I have a new short. This is the idea. So and Discord and some workshops if you're interested. And now the first question, always get, you're talking about serverless, but you are locked into a cloud. And usually, it's not like it's my decision to go to the cloud, exactly the same as 10 years ago. It was never my decision to create microservices. If people wanted to have it, so they got it, but I couldn't understand why. I was always for monolith, and I still am. You will see in a second. And so if you go to the cloud, so you are locked in somehow to the cloud. The question is, what is actually the problem? And from my perspective, this locked in or not, I actually don't care. What's more important for me is how fast can we switch clouds? So let's say I'm going to AWS and I'm completely relying on the proprietary AWS technology. How fast can I move out to Azure or from Azure to Oracle Cloud? This is what interests me. Portability, yes or no? No one cares, because if I will spend 2 years for portability, and just in 1 day to switch the cloud is not worth. You remember DAOs, switching databases? So we spent months abstracting from a database, and what happened? The databases outlived our applications. We're still abstracted, right? There's the same discussion in the clouds. So code portability, cool news, absolute portable, 100%. So usually there is a lot of proprietary code, except you are accessing Cosmos DB, DynamoDB, Kinesis, SQS. Of course, there should be some dependency because we are using the features, but there is no really nothing which makes the cloud proprietary. So infrastructure portability, this is interesting one. This is mostly forgotten by managers. So in my project, say, okay, we go Kubernetes, then we are portable, and I don't know whether you set up already Kubernetes in the project. So what you have to do is, in the cloud, you have to set up the cloud, VPC, subnets, net gateways, internet gateways, availability zones. This is the level 1. And then you deploy the Kubernetes with after tooling. For instance, AWS, there is CDK and CDK for Kubernetes. Two-stage process. If you never did it, I think you will spend 1 week with Kubernetes. Or I could use Fargate or on Azure App Service, and I'm done with a day. And if I have to switch between clouds, I need a day. This is what I'm talking about, right? This is exactly the same 10 years ago. We can use JPA straight, or we can wrap JPA and hope one day the JPA will disappear, be replaced by JPA 2 or whatever we have. ChatGPT JPA, right? So never happened. So all the DAOs and all the stuff was a waste of effort. So this is actually the interesting part. So infrastructure portability, what they're depending on in the cloud is usually networking and security. This is the highest dependency you have. You spend a lot of time fiddling with security or networks. At least this is what I did. And I actually never changed Java code, or Docker is Docker. It runs everywhere, right? I hope I'm right. If not, you have different experiences. You can say now it's not true, or afterwards, you can say okay, what they are saying is not right. So the really problem is data. If you have a terabytes of data and you move the data to one cloud, it's really expensive to move this data to another cloud. Yeah, but this is not solvable, even not with Kubernetes. Agreed? Who doesn't? Everyone agreed. Okay, cool. So next, what I'm talking about is not necessarily applicable for web scale applications. So I'm not working for YouTube or TikTok. My clients are larger companies, but the use cases are, I would say, boring. Like still CRUD with database and more or less CRUD with database, right? The database is a little bit different, but this is what happens usually in maybe some queue in between if it gets boring, but usually, just boring things. So in web scale, what is in web scale? There are no vacations, no 9 to 5, unpredictable loads, and I guess you have several hundreds or thousand transactions per second. This is what I will say. This is web scale. This is usually, I would say, if you are in this area, it is not necessarily a good idea, or maybe serverless becomes too expensive. This is what I'm saying here. Why? Because serverless is always more expensive, 20-30%. Why that? Because there are additional layers on top of EC2, of your virtual machine. It has to be expensive. So the entire trick of serverless is, because in enterprises, this is the next slide, enterprise applications, they are working from 8 to 5 or from 9 to 5. This is a mistake, actually, usually from 9 to 5. And there is no traffic at nights and in weekends. So what it means, everything scales to 0, and then it is very cheap. Agreed? Okay, this is the entire trick. So what it means is, what's changed in my years is it's not like we're talking about OSGI and DAOs, and my clients are afraid that one day DB2 is going to be replaced by Oracle. No, it is like, what usually happens in the last 2 years, someone comes to me with the invoice and says, look, this is too expensive, what we can do about that? And what also happened in the last 2 years is, in many companies, they got cloud credits, and now it's over with the cloud credits, and now you have to pay the first invoices, and then they say, okay, we didn't know that a simple service costs, 1K euros per month. Okay? So cost-driven architectures, everything is driven by costs. I only know one client of mine that say, okay, we don't care, we have unlimited budget, stop talking about costs. So in this particular project, I say, okay, then we buy the largest EC2 machine with 500 CPUs and we are done, right? What I can tell you, this is the simplest possible solution, right? So it's not italic because, cluster and so forth is unsolvable, but it's a way easier if you have unlimited budget. And by the way, I'm expecting a question here, really. So it should be interactive, if I come every 10 years, so at least a little bit more fun, right, at the conference. So what this is, I did it yesterday in train, so maybe it is not exact, but this is the costs of an AWS Lambda running Quarkus, 2 transactions per second, and 2 GB of RAM the entire time. And it will cost you $15 a month. So what it means is, in most enterprise applications, a microservice could run, I would say, 2 transactions per second. For an enterprise app, day and night, the entire month is a lot. Because usually you have a peak and at night no one works, at least not in Germany, right? So what it means is, In my projects, in the enterprise apps, it is not uncommon that they pay nothing. But in the higher load, they will pay a lot. This is the difference. So for web scale, this could be thousands. Okay? So what it means is, we have to start, the first pattern, which I forgot to mention on my slides, is everything starts in Azure or AWS calculator. So what is the alternative? A little less serverless, but still serverless, but there's lots of arguing about that. This is Fargate. So if I have one node, Fargate, and it runs all the time, and I have 8 gigs of RAM, a little bit more, because I need them more, so then I will spend 50 euros a month. This is minimum, because I need 2 nodes, so I will spend 100 euros. I need the load balancer, which costs 20 euros, and VPC. So with this setup, you will, for 200 euros a month, you can run the service all the time. So now the job is to have a proof of concept and see what is cheaper. So everything is about costs. If not, I will, of course, push always. No, not always. The problem with Fargate is it needs a VPC. I don't know who set up already a VPC. Who really liked that, the experience? No one. So why not? Because on all clouds is the same problem. You know, VPC, CIDR, IP address ranges, you have to create actually 4 or 6 subnets with, CIDR, so slices of the IP addresses. So there's in CIDR XYZ, a calculator, there's lots of to do. And in Lambda, there is no VPC. So I'm in projects right now where we have a policy rule that you are not allowed to create a subnet, IP address, or VPC. This is serverless. Cool, right? So why cool? Cheaper. Okay, green IT. Next thing, what hit me, and last year or 2 years ago, roughly, it's hard to tell, but what happened is I got more and more questions regarding green IT. And I say, why everyone asks me about green IT, even developers? And I ask a manager, and what happened, I see you in a second, but what happened here, this is an official study, there is a study, there is in the URI, and what you can see is Java is actually very good regarding energy efficiency and performance. So what it means is, the faster Java runs, the more money we will save in serverless mode, because you're paying for gigabyte second. This is one of the reasons why I'm doing Java all the time. So to be honest, I could also use Rust, but I like Java a bit more, but I have absolutely no interest to learn Ada, for instance, right? So, but if you take a look at the down, you see that Ruby and Python are 35 times worse than Java. Okay? So if you have an application which is serious means a little bit algorithms, not just calling to the backend. So something, a for loop or whatever. And so it means Java is really fast. Of course, C is faster. Rust, okay, agreed, is faster. And Java is not that great with memory. The interesting part is you could use GraalVM to optimize it, but you don't have to. It really depends on the cloud. In AWS on Lambda, you have to buy with memory CPU. With 2 gigs of RAM, you get 1 CPU. Okay, so the consequence is I run my Quarkus always with 2 gigs of RAM to get 1 CPU, because we pay the least amount of money with it, right? So on Azure, different pricing model, I use GraalVM to optimize. Okay, so this was about costs. And this is the nice German law. Who can read it? Who can speak English? Lieferketten Sorgfaltspflichtengesetz, LKSG. This is one manager told me, we will be forced to do that in 2024. Every company, a larger company in Germany, will be forced, I actually translated this from SAP, will be forced to somehow, say the CO2 emissions, even from the servers. And the cool story is, serverless is actually very efficient when it's CO2. Because Docker container runs 24/7, and the serverless function only runs if it had to run. So it is greener, and what I suspect what we'll do, we will get a lots of marketing, slides from companies that they have a green IT because they run serverless. I suspect it will happen next year. But this law will be out there, and I got lots of questions about that. Which and now I understood why now everyone thinks about green, not because they are greener, just because the law with the funky name. So I wrote down some patterns. They're not patterns, more like agenda. I just, in the train, tried to think, okay, which question I got, and what is the best practice. So no surprises. So my Lambda functions are extremely big. It means the biggest one, we write one function for over 1 year, 115 JAX-ORS endpoints. So this is extremely fat functions. So what we are effectively doing, we are moving our own old Java EE and microprofile applications to Quarkus and launch it as Lambda. And it works surprisingly well. So there is almost nothing to do from on the source code level, and it just works. How can it work? This is the trick done by Quarkus, and Micronaut is also capable to do that. So what happens is, there is an API gateway, load balancer, a VPC lattice, and something I forgot. There are two gateways, application load balancer, lattice, and function URL. And what they are doing, if you hit the cloud, they are creating an HTTP event, which is consumed by Quarkus, and Quarkus invokes our old JAX-ORS application, so there is no difference. And Quarkus eliminates the use of reflection, so it's crazy fast. And fast means 8 milliseconds, 10 milliseconds. So the calculation I showed you was 100 milliseconds. In fact, if there is no backend call, it is a lot faster than this. Questions so far? No questions. So it's a pity. Maybe next time I will ask for the first session. So how does look like? I created two projects for you. Maybe we start with the S3 project first. This is the Lambda, and if you take a look at the source code, you will see that maybe. So there is actually no difference. So the only thing I did, I used the recent Jakarta. 2 months ago it was Java X. So it looks like it always looked. Actually, if we find some time, I can open my 2012 DevOps session, and the code would even run as a Lambda. So this is the nice story, always the same source code and a little bit, different setup. So the question, what the interesting part is also, what I can do, I can say Quarkus dev, and it will start hopefully if nothing running, and I launch a Quarkus locally right now, but this concludes the question how I debug my cloud applications. And the answer is we run them locally and they connect to the cloud. So I hope I have still internet. So what I can do now, I can try to deploy the entire thing. This is, and I will use Java for the deployment. Build and deploy, don't ask. This is my script. Because it takes 70 seconds, and if I do VPCs and stuff, sometimes I have to do it. It can take. This is a Node.js. I don't like to update this. It takes too long, but yeah. And what this is right now, it uses CDK to deploy the Lambda to the cloud. I will actually show you what happens behind the scenes. But what it means is the same source code runs a serverless function. It runs locally, and I can run it in Docker if I like. Okay. So this is not like I'm very. The question is, what's the magic? So now the entire thing is provisioned. The only magic is we need one extension. This is this. And what the extension does, instead of emitting a jar, it emits a function. So it just zips the classes. This is what happens behind the scenes. OK, so you saw, OK, this is the function. So I could actually call it. This is my, somewhere is the URI. Here, HTTP URI. So if I go here and call it, this is cold start, very cold. And now try, I forgot the endpoint, but let's try this one. This is very cold. So you saw it costs, it is 4 seconds, which is very slow. And the subsequent calls are faster because the function is up and running. What I didn't schedule here, no, what supported is crack. I disabled crack for the, or snap start. I disabled it right now because it takes longer for deployment. It optimizes for every availability zone. But it halves the time of cold starts. So what I did, I deployed a monolithic Lambda with all microprofile extensions I know, so all the Java EE stuff, and it started in 4 seconds the first time, and then I don't know, in under 100 milliseconds. If you go to the console, you will see that I will pay actually only 10 milliseconds or something like this. Questions? No questions. I go faster because we have. I would like to present you as many ideas as possible. And so the next one is Nano asynchronous event-driven function. So the name is not right, but it is exactly what I meant. What I meant by the second point is just a POJO without any external dependencies, which ships as Lambda. So I have it already here in my as listener, and this is what I talk about. So this is a function, which is just a POJO, with one method on upload with S3 event. And what happens here, it is of course depending on S3 in this particular case, right? Because if I'm receiving S3 event, I have to be depending on the S3 event. But S3 is almost a standard. It is even supported by NAS storage, and Oracle supports S3, so it's not that bad, but still absolutely depending on cloud. What I'm going with it, I have here a Lambda, which looks like a POJO, and the method on upload is invoked. And this is S3 or Amazon specific, and these methods no more. Because what I can do here, I can say, okay, I can pass, I can extract the S3 event and just do whatever I like in a Java record and pass it to the backend. What I observe, developers try to build a lots of lambdas and then complain they're hard to manage. It's like, why are you doing this? Because it's best practice. And I ask why, and what I noticed is that the micro lambdas come not from Java, rather from Python and Node.js, because they have sometimes trouble having lots of small of a large function is harder to load. But Java, my experience is, you can pack as many Java classes as you like to a Lambda. There is no difference in performance. Dependencies are a problem, right? So if you put all your log frameworks, and all JDBC and caching and configuration and entire commons length framework, this will take a little bit longer, maybe. Depends on reflection. It's not as bad because the networking inside the cloud is actually very, very, very fast. So you can pack actually as many classes as you like. Hundreds of classes, not a problem. So I mean, monolithic lambdas, very good for productivity. What I did here is already the next pattern. The next question is, how many lambdas an application can have? I have one application with one synchronous lambda and one asynchronous lambda. So what happens here is, I have here a greetings resource with greetings, and I say post, it goes here to write. With the write, it creates an UID and then goes to S3 store. And S3 store is, of course, proprietary, has to be. And I'm writing here to S3. The cool story is, the other Lambda listens to the changes in S3, wakes up, and processes the object, just for fun, to show you both. And the second Lambda has no dependency, just a POJO. The first one, I'm using Quarkus because Quarkus eliminates reflection, Micronaut as well, both I know, and both are perfect for such lambdas. Okay, so what it means is I can actually take my old DevOps 2012 code, so I can at least show you how it looked like, 12, and slide generator I created. I have no idea, but if you show you Java business, business security provider, you see it's not that much difference. The only difference is Java X. Because of Java 7, now we have Jakarta. So with a little bit of refactoring, I could actually, the 11 old DevOps 12 code would run as serverless Lambda, which is actually interesting. So I was not lying 10 years ago, right? So it's okay, you said it is nice. It was nice, and it still is. So this would be, of course, Java record, not such a class. And we have slides, boundary, code generator with, producer a little bit exaggerated, don't use it a lot. And slide generator, the only thing is I wouldn't use stateless are not available. I will have to replace it stateless with application scoped in Lambda case. So search and replace all stateless with application scoped, and you are golden. No questions still. So very shy developers, right? So what I told you, so it is actually good, has an entry point, and one synchronous Lambda, which is monolithic, All asynchronous event-driven lambdas are usually POJOs without any dependencies because you don't need anything. Why I need dependency injection if I just get the event and process the event, I can just work like, 1995 and just invoke new. It's really nice. So serverless archive, you saw it already. So what it means is we have a stock one Maven module and as many lambdas as you like. So, but this module is nicely structured. So we have boundary control entity, what I'm doing. And by the way, I had the opportunity to talk with Ivor Jacobson, and Ivor Jacobson is one of the three amigos of UML, and we talk about BCE. And he say, okay, you do it the right way. So I was revealed because I think if Ivar will say, this BCE, I'm using it wrongly, then I will delete the podcast. But he said, okay, this is nice. So, so what's important is the internal structure, boundary control entity. But the boundary can be asynchronous lambdas or synchronous lambdas. And one important thing, this is misunderstanding of all Java developers, or most Java developers, you can have one lambda with 10 million functions. It doesn't matter. They get dispatched. It's not like, one function, one lambda. Okay? So this is, you can have as many methods as you like. So we have one monolithic lambda entry point with many methods, and the asynchronous lambdas, they have one entry point method. This is true. Serverless archive, so it means I have just something like a zip, which contains lambdas, and the zip is deployed multiple times. So app as a function, this is what I meant. I wanted to say I had microservice, and I never liked actually microservices because microservice is too fine-grained. What I really mean is an app as a lambda, no problem. So when you would implement another lambda, if you have the same story as microservice, you say, okay, I have 2 release cycles, or I have different security requirements, or 2 JVM versions. There has to be a reason. But one lambda is just fine. Self-provision runtimes. This is the newest hot stuff. With Java, not a problem at all. You saw it already in action. So what I did here, this is just structure, and you will also find the template on my GitHub account. So this was the entire trick here there's no trick, it's just Maven. You go to CDK, stands for Cloud Development Kit, and what I would like to do is to take a look at the code once again. And so what we have here, this is a CDK application, and this is completely depending on AWS. And why this is not used? Because I can decide, depending on the costs, whether I would like to use the application load balancer, HTTP API gateway, REST API gateway is just cost dependent. It's no impact on source code. Because application load balancer costs you the entire month 20 euro, and the heavy load costs you far less than HTTP API gateway. HTTP API gateway costs you nothing, but under heavy load, it will be orders of magnitude more expensive than ALB. So the entire circus here is just because of costs. By the way, the entire cloud circus is just because of costs. So all the cloud architectures are driven by costs. If they are not driven by costs, then they are pointless, if you think about this, right? Because you are doing something in the cloud, because usually the hope is it has to be cost effective. Other than that, it will be extremely expensive. So I have here you saw it already in action, it was deployed. So, and that's the function URL stack. And what I'm doing here, I'm saying here, I would like to have one Quarkus Lambda, and the Quarkus Lambda is the monolithic one, and I would like to have a storage bucket and a function, and now comes the cool story. I say bucket dot grant, read, and write. And this comes from AWS. So AWS is in charge now to set all the permissions. Why is this so cool? I'm right now in somehow, security relevant projects, multiple projects, and we are going to be audited. And the cool story is, I send him the code and say, look, you already approved AWS. This is my line. So now you can review maybe AWS code, but I'm out of, never declared any roles. It's just this line, grant, read, and write. So what this means is, I'm creating here my fed function, and this is Java class. So I go in here, fed function, and snap start yes or no. So this is actually, I'm using this as template for my commercial project as well, so it's a little bit more complicated. So I can decide, would I like to go with snap start with crack or not? In the conference, no, because it deploys slower. And the entire deployment is this. To deploy a Java function to the cloud, it looks like that. What it says, I would like to have Java 17, and I would like to have either ARM or Intel. ARM is 10% cheaper and also faster. This is my zip created by Quarkus with all the lambdas. And I say this is the memory size, function name, environment is a map with key value pairs. They become environment entries. You can inject them with microprofile config, for instance. And the timeout, and this is basically it. This is an interface. So what it means is, one of the agenda points is, we create a jar and put it to Nexus or Maven repository, or whatever it has, Artifactory, it doesn't matter. The cool story is, a new developer just says, new app with some parameters, and it's done. What it means is, because this jar is shareable, in our projects, every developer gets an own AWS account. And why that? Because now you can freely test in production-like environment. There is no difference to production. And because it's serverless, it costs you nothing. Try that with containers. If they run all the time, you will pay a lot. So we already had, the circus with some projects. We don't like the test because they're expensive. It's like, okay, I hear it, for 20 years, or even more, since beginning of Java. Now it's time, to make it better. And the cool story is, account is just a number. So it means your account will behave exactly the same as production. Okay? So, yeah. Oh, the line before. So I can... okay. What happens behind the scenes, the CDK creates a CloudFormation script, and the AWS architects know what grant, read, and write do, and they set a role with lots of permissions, which are predefined. And I was lying a bit what we are doing. We're starting with that. Then we have the role. We look at the role, and there are some permissions which are not needed. So then we need the role as an input and remove unneeded permissions afterwards. But this is a very good start. And the cool story is, if you have a function with a bucket or a DynamoDB table, for instance, this is hardwired. Tried it by hand, with stars or whatever. So every function can only access this bucket, and this is hardwired. Okay, cool. Very good question. Thank you. So you get at least, a pen afterwards. So come here, and because it's heavy, so you have to take it. I underestimated, the weight of swag. Now, serve provision runtimes, exactly. So we walk through the code, and this is like a big deal in Node.js and Python. I would say in Java is just Maven, basically. I have 2 Maven projects. And the cool story is, I have here, this was the Lambda. And the only thing is, wait a sec. So this was end bucket. So what I do here, I would say, okay, I would like to have an S3 bucket with public access block all and bucket name whatever built. And what I could do, I can specify additional features. What happens behind the scenes, CloudFormation happens and is deployed. And this is an official AWS SDK. You can just use it, and this is developed by AWS, and AWS also develops cloud. So in my enterprise project is no discussions. Okay, we know Java. We get an CDK, from AWS, so we can just use it, right? Now the cool story is, now you have, I would say the first killer feature of this approach is this one. So if we go to S3 store, you see I'm using here the S3 client without credentials. So what it means is I can launch Quarkus locally, debug it, and it will connect to the S3 to the cloud and will work. So this is the most common question, how I test the thing. So I don't have local stack, no test containers. We don't work, with Docker locally. Every developer has an own account. You run build and whatever. You provide the account ID. It pushes to your account. Every account has a free tier. It costs you nothing. And you can debug, do whatever you like locally, and it will use the resources in the cloud. And anytime you can delete the stack, CloudFormation, and everything is gone. We do it for years. It works perfectly. And if new developer comes and asks and installs test containers, we deinstall test containers and containers. I tried this first, and it says great. Like it was before, no container, you can just run Quarkus locally. I already did it. I started Quarkus locally. The only thing is, be aware of timeouts. So if you're working locally, it's a 1 second timeout. Maybe the ping time is not enough. In the cloud, you can have timeouts of 10 milliseconds, very, very, very fast. Okay, let's go through the slides. So cloud native services. This is harder to explain. And now it is the most common question, what about connection pooling? So for that, I created another example with DynamoDB database to show you the code, because it's hard to explain, but really easy to get if you see the code. So, so go away from the slide generator. And it was DynamoDB database. And what I wanted to show you is Lambda first. Okay. So what this is the DynamoDB client. And by the way, all the, not only in Amazon, in most clouds, all the SDKs look the same. It's basically HTTP calls. What I try to express on the slide, but it's really hard to explain this, is, for me, something is cloud native when CDK and SDK are both available through the same channel. So what does it mean is the following. If you take a look, wait a second, I will just, where I'm here. Okay, and I would also like to show you the CDK of that. So in the another example, it's very similar. It's also CDK, Cloud Development Kit, and there's a Lambda stack, but a little bit simpler. And what I'm doing here, I'm saying here create table. And here, a DynamoDB table is created. So now, the Dynamo table is created, and look at that. Here we have the table again, and then I see table grant, read, and write data to function. Okay, what I mean by that, I use CDK, so serverless resources are already there. There is nothing to install. The DynamoDB service is running for years, and this is tier 0 service, highly available. What I'm only doing, I'm saying I would like to have a new table. And I get the table, and then I can set up security. So this is, I don't like DynamoDB, but if I have to operate in the cloud, it cannot be easier than this. I just say, give me a table and I have the table. Try that with RDS, Postgres, Aurora V2, MySQL, or whatever. You will spend at least half an hour to set up the database. You have to have 2 specific subnets in a VPC. And the first question you get asked is, what about backup? And what about maintenance windows? So you have to decide, what happens with that. There's no backup, no maintenance windows. You have point-in-time recovery you can set up, but there's not, necessary backup here. So, so what it means here, I created table with permissions. But if I'm using, for instance, an MySQL or Postgres in the cloud, at the end of the half an hour, I have an empty database without any permissions, without any tables. So now the question is how to provision the tables. There's a difference. So in current project, we use DynamoDB for performance and other reasons, and also cost reasons. And the cool story is every developer that does that and has his own DynamoDB table in account, which costs you nothing because it's pay per use. You have to invoke it millions of times, and then you pay a few euros. Okay? So what I'm telling you is not like, the clouds are nice to develop. I don't like actually the API of DynamoDB S3, but they are, if you do it right, it is orders of magnitude cost difference. And at least in Germany, the company starting, to notice that lift and shift can be very expensive. And the first project are already questions. So this is what happens in my world. And we show this in many companies. People are not even aware that you can do such a thing, that run, a Java application as Lambda and pay almost nothing. Questions? Quick questions? Yeah.
You show examples with Quarkus.
Uh-huh.
What if you are on Spring Boot?
I have no experience with Spring Boot. What I know, it starts slower than Quarkus, but I cannot say it loud because there's lots of heated discussions about that. But that's the problem, it's slower. Yeah. And if it's slower, it's just more expensive, and you have to optimize more. And but I have to tell, I don't know, because I only use Jakarta E and Java E and microprofile, and then Quarkus happened, migrated to Quarkus, and whatever I do is Quarkus. I would really like, Helidon is great, but Helidon doesn't support the function stuff yet. Micronaut is alternative. So if you are Spring, Spring projects, migration to Micronaut is possible, and you will like the APIs. This Graham Roche is here actually, and he created, I think, was one of the creators of Spring Data. Very good. Other, yeah. Oh, for Lambda depends on the endpoint. If you have HTTP API gateway, there's HTTP API monitoring. If you're using ALB as ALB monitoring, and if you like, you can write logs in EMF format, this embedded metrics format, and then you get Prometheus-like metrics. What we don't do, this is interesting, very good question. We are not exposing micro-profile metrics. I like them a lot. I'm not doing this. Why not? Because then I will have to set up Prometheus, which gathers the metrics, and the Prometheus is expensive. And because of costs, we are not using Prometheus in the cloud, just because of costs. But in the one projects, when they told me, the budget is not a problem, the first thing I will do, or we did, we installed Prometheus, because they have budget. This would be, it would be a problem. The problem is if the Lambda gets cold, it forgets about the metrics. But if Prometheus will scrape the Lambdas, the cool story was, this is like, pinging Lambdas all the time, they would be never cold. We do it with cron, actually. This is a dirty hack. Do it every minute, and it's never cold.
Are there specific workloads you would not use with Lambdas, like IO or iCPU or something like that?
Lambdas are very capable. They can be up to 10 gigs of RAM and I think 6 CPUs. So what it means is if you have 100 transactions concurrent, you have 600 CPUs. This is not like, it scales, with a process, and 600 gigabytes memory, but it is expense. Just the costs are the problem. So if you have 1,000 transactions per second, so it is 500 times more expensive than this what I showed you. So I would say if you are web scale, if you are really under high load, I think the cheapest would be EC2. So I had in a workshop and a startup, they bought a large EC2 machine, and this was the cheapest possible solution. But they have a product and they care about the product, right? So if you have projects, maybe you cannot do this. So, yeah.
But like with, suppose low workload, but heavy computation, like, I don't know.
Heavy computation, which with Java not a problem. With Python, you see, is very bad for environment, right? So, cloud native, I hope you got me, right? The same is true. I like really Kafka, but I wouldn't use Kafka in the cloud. The same problem. I have set up Kafka cluster first, care about backup, and then I get Kafka without topics. Then I have launch the Kafka topic, and then I have do certificates, whatever, by myself. But if I use proprietary SQS, SNS, or Kinesis, for instance, I just say, give me a queue, and I have a queue, and the persistence is solved. And then I'm, of course, somehow depending on SQS. But if I go to Azure, there is, I forgot, this is an MQ similar service. There's even a table, Azure to think. I change a few lines of code, and I hope it will work as well. And my Kafka on AWS, from my AWS will guaranteed behave differently on Azure. Right? This is my experience. It's not like magically it will work the same. So absolute portability, forget it. This was the dream for 30 years in Java, or maybe 25 maybe. So opinionated infrastructure resources. If you will have more time and we go to the code, you will find, if I create a Lambda, or I can show you this, and if I go here to CloudWatch, this is the log aggregator, you see that the name of the log groups, which are folders, are the same as the project. So what we're doing, because it's Java, we say if we create a project called DevOps, then we get DevOps log groups, DevOps Lambda, DevOps certificate, and we take everything consistently that we can find easier the resources. So we are very opinionated regarding the resources, always the same naming, because we can do this. We have the self-provision runtime, right? The CDK, the project, and the infrastructure, and the project is the same Maven module, right? So for instance, we have the expiration, the log groups, and so forth. So BCE, boundary control entity for infrastructure as code, you saw it already. So for instance, if you get the, if you're interested, this simple template, this I will push to my AHEX workspace on GitHub. but there is an official CDK, or official, what I created, Quarkus CDK template. You can just clone it. So you had Hello World example. This is based on it. And if we take a look here, this is the CDK. You see, this is this is too easy. If we go to the S3 example, Lambda, Quarkus, S3 read, and CDK. I think here's, I left. Right. So as you can see, what I did here is, okay, in case you would like to have LB, this is the LB configuration, but I treat it as a Java code. So this, okay, this is my Lambda stack with application load balancer in case you have heavy load. So then HTTP API gateways, which is this one, is maybe less interesting. And if you need DNS certificate, pick this one. If you don't need certificate, pick this one. This is the cheapest one. So it's all cost driven. Okay. Cool. So reusable self-contained constructions, Maven modules. So this constructs is the term from AWS, and we are doing is, if there is a Maven module, you know, let's say we created a Lambda with CloudWatch and DNS certificate, and you have a project, it's like all our microservices need a DNS certificate, which is automatically renewed, and I don't know, we have some configuration. So it is actually a good idea to create a Java class, push it to a Nexus, and the next project, you just pull it, and you have reusable infrastructure across teams. And the cool story is, if you find a security bug or a bug, you can fix it for all projects in one place. Okay. So my clients were, you know, huge fans. Some clients were fans of Terraform, for instance. So Terraform was for me a lot of writing actually, and you know, for and if loops were not that easy, I would say. But now with the fork, they are less enthusiastic about Terraform, I would say, and they changed the license. And so I would say we Java developers can use Java code, and when we write, you know, infrastructure code in Java, we can be very productive. This is the message. And I would use actually everything. We use unit test, AssertJ. Actually, what you do is all the time applying infrastructure as Java code, actually, right? So then, this one goes one step further. What I told you right now, we can create, you know, Lambda, let's say with certificate and S3 bucket and whatever you like, right? So, and put it to Maven. So what we do actually in a product, we make it executable. What about if we add a main method, have no and Maven, I forgot actually the name of the Maven plugin, which creates an executable jar. It is Shader, I think, right? Maven Shade. And now it's cool. What you can do in a CICD pipeline, which is serverless, by the way, for the same reasons, we create a jar which is executable, put it to S3. S3 is versioned, so there's a versioned S3. It can never lost one of the cheapest and most secure resources, S3. And then in the pipeline, we do AWS S3 copy from S3, and now it comes Java minus jar infrastructure. So our infrastructure provisioning is one-liner. Why not? Agreed? One-liner. Because the entire thing, you saw this, right? What you need some environment entries. The serverless CICD pipeline already has the roles and credentials to execute it, is one-liner. What only needs is permissions to execute CDK. Okay, so now no code with Java. This is hard to explain because no code with Java is crazy. But this is what I meant. So wrong button. What this is a little bit evolved, but this is just CDK and there is no business code. And what this thing is doing is following. It says there is an event bridge, which is a great thing. So what event bridge is like, it is hard to explain, but all the cloud events are gathered in event bridge, and you can just subscribe to the events. So this is basically it. And what this thing does, it says, okay, if a specific event happens in the event bridge, I'm transforming the event to code build event, and CI/CD process starts. So what it means with this piece of code, we are plugging together two cloud services, and at runtime, there is no Java code. The most secure and the most cost-effective or cheap solution, just the Java architects did it, right? Ask the architects. So. This is what I mean. So no code is the best solution. So for instance, I give you an example, similar, upload. What we did for years, multi-form upload, JAX to REST easy, whatever. You upload something, temporary folder. So what is the serverless way of doing it? Just upload first to S3. If it's uploaded, S3 is crazy fast, secure, and so forth. S3 emits an event. You can listen to the event, and you have the file. You're done. You can throw away, a lot of code. So what I'm saying here, actually, if you go to the cloud, just use the cloud. And not the same mistake we did, for years. We have a database, but we've wrapped it with 20 layers because one day it could be replaced. And now we cannot do it anymore because, the Node.js and Python guys, they behave more reasonable. And they will just kill us. If you start, to abstract the entire cloud, say, okay, one day maybe AWS will raise the prices or Azure. So okay, it could happen, but I mean, the question is always how fast we can move out from one cloud to another. And in this particular case, I will have to delete the CDK. You saw it was like 200 lines of code. The business code is almost identical. And then I will have to use Bicep in Azure, for instance, which the Azure native way is also a little code. So it's not a huge problem, I would say. Okay, so now what I promised you, time is up. No code with Java, but we actually did everything. So we managed to talk about the ideas, and yeah, any questions? If we had more time, I would show you more code, but it is not like, the idea of the talk is not to promote the cloud. I still run my own server, no difference, and on-premise is always cheaper, but in clouds you can make things you cannot do on-premise. For instance, in the high security project, we had to go almost to the cloud because we get all the compliance reports from the cloud. They have no compliance reports from our own data center, for instance, right? So then I'm in charge in the architect, and I am in charge of security, whatever. If I do the CDK, I mean, it is not my problem if grant read and write doesn't work, right? I review this, but it was implemented by AWS in AWS. If I choose any crazy framework to do that, I will have, to look at this, what happens behind the scenes. So so I would say, and also now, it was a funny story. I was asked to write an operational manual. And I say there's nothing to operate. So we have nothing. So if you take a look here, we don't have operating system. We don't have any certificate. We don't have, if you take a look, for instance, function URL stack, there was the Crocus Lambda. We don't even have a, where is it, Crocus Lambda and functions. So this is actually the gist of the entire talk, right? So what I only saying, please pick the release Java 17 you have. I'm not shipping Java. This is Corretto, patched by AWS. And my clients have contracts with AWS. So if AWS doesn't patch Lambda, Corretto, or JVMs, okay, then managers go to golf course and just talk with each other. I cannot do anything about that. Then architecture, I can say, okay, ARM or whatever, ARM or Intel, and this basically it. So this is actually my my infrastructure. And if the Lambda dies, it will get restarted like EGB, 20 years ago. So there is nothing to keep running. There's, if it dies, it died and it gets restarted. So I had a fight with a manager because he wanted an operation manual. And so, okay, what I can tell, go at AWS console and see whether it is running. So there is nothing else to operate. So you cannot, in serverless mode, you cannot, see whether DynamoDB service is running. It always runs. If it's down, the entire cloud is down. I don't have, if the DynamoDB is down, there is no Teams, no Zoom meeting. I think nothing, right? So this is actually the interesting part. So my point is, if we go to the cloud, we really go to the cloud, or we stay on premise. So it's not like we have to go. But what I don't understand, we go half to the cloud, do all mistakes we did on premise, and then, complain it's too expensive, and say, okay, but why you are in first place? So this should be clear vision what we are doing there. So I'm over time anyway. So any questions? So I think it's the last session, so maybe you have more time. So At least please pick some pens or something, because I have to go by train back, and this is too heavy, and I don't like to throw it away. So, any questions? What is cheaper? EC2 reserved instances are 70% cheaper than usual instances. Under heavy load, they are cheaper for sure. So I think if you already get 100 transactions per second all the time, I think then EC2 is going to be cheaper. But you have to be careful, because you need 2 EC2 machines, 1 load balancer, right? And if you have database, you need 4 subnets with NAT gateways, and you're also paying for the bandwidth between and you're also paying for the bandwidth between availability zones. So, but you are right. On the heavy load, EC2 is going to be cheaper for sure. I'm absolutely sure for that. But I'm talking more about enterprise apps, and they don't have the entire time 100 transactions per second, right? And what I do actually at the beginning, I go to manager, and we do together the calculation. So if you assume 100 transactions per second, and there's the Excel, and they say yes or no. So I don't care, really. I really don't care. I only try to make it transparent. But what happens if you start with calculator? I never got the contract for Kubernetes. This is what I can tell you. In the last 2 years was over. So we always did this. This is what I can tell you. Okay? Thank you. Then I hope we are done. And see you next year, maybe, right? Thank you.